Alright guys, here we have an A-level 9 marks question, and we have this equation y equal 2x squared minus 8x root x plus 8x plus 1, and we want to prove that this curve has a maximum point at 1, 3. Now, when we're talking about maximum, we need to think of differentiation, and here, to find the point of maximum, first of all we need to differentiate the y. So I'm going to find dy dx, which is 2, the derivative of x squared is 2x, so times the 2 is 4x, then minus 8, then we have a product x and root x. I'm going to use the product rule, so the derivative of the first would be 1 times the second, so 1 times root x is root x, then plus the derivative of the second times the first, so x times the derivative of the second, which is root x, and the derivative of root x is 1 over 2 root x, then plus the derivative of 8x would be 8, and the derivative of 1 would be 0. Now I'm just gonna expand to make it nicer, so this implies that dy dx equals 4x. Then if I expand here, I'm gonna have 8 root x, and then if I multiply 8, then if I multiply minus 8 times x would be minus 8x, so then 8 divided by 2 would be 4, so minus 4, then root x, because x over root x would be root x, and then plus 8. Now this is our dy dx. I'm going to make it nicer again. Dy dx would be equal to 4x, then minus 12 root x, then plus 8. So this is our first derivative. Now to find critical points, I need to put my first derivative equal to 0, right? Now I'm going to do another thing. Since we want to prove where the curve has a maximum point, and we know that the curve would have a maximum point where the first derivative is positive, so I'm going to put, instead of putting my dy dx equals 0, I'm going to put it greater than 0, right? Greater or equal to 0. So dy dx positive, this implies that 4x minus 12 root x plus 8 would be positive, right? So if I manage to solve this inequality, I would see where my curve is increasing, right? So I'm going to substitute root x. I'm going to substitute root x by y, so y equal root x. This implies that I'm going to have 4y squared minus 12y plus 8 positive. Now I'm going to write the equation, the associated equation, so 4y squared minus 12y plus 8 equals 0, and I'm going to solve it. So this implies that y equals minus b half, so plus 6, plus or minus square root of b half squared, so 36, minus ac, a is 4, c is 8, so 32 over a, which is 4. Now this implies that y equals 6 plus or minus 2 over 4. This implies that y12 equals what? We're going to have 6 plus 2 is 8 divided by 4 is 2. Then 6 minus 2 is 4 divided by 4 is 1. So we have, from the associated equation, we have two solutions, 1 and 2. But we needed to solve this inequality, right? This one. So basically, I'm going to look at the sign of this. So this is positive and this is greater or equal. So it means they have the same sign, right? So when they have the same sign, the solution of the inequality would be the exterior. So it means that our curve would increase when y is less than or equal to 1, and when y is greater than or equal to 2. That's where our curve is increasing. But we substituted y to be root x. This implies that root x is less than equal to 1 and root x is greater than or equal to 2. and then I'm gonna square everything. So x less than equal to 1 and x greater than or equal to 4. So in this interval, our function is increasing. So let's say we have 1 here, 4 here. So it means here is increasing, and in the between is decreasing. So our basically function would be like this, right? Where the maximum point would be at the point 1 as we expected. So that's what we wanted to prove. And to find the y coordinate, which is 3, so they said that prove that the curve has maximum point at 1 and 3. So at 1 here we would have the maximum, right? And let's try to find the y coordinate. To find the y coordinate, we just sub in 1 into this equation here, and therefore we're gonna have y equal, if we sub in this, we're gonna have 2 times 1 square, which is basically 1, minus 8 plus 8 plus 1. 8 and minus 8 cancels out, and this implies the y equal 3. Therefore we have maximum point at 1, 3, as we wanted to prove. Now they said here, find the coordinate of the other stationary point of the curve and state its nature. So as you can see, the other stationary point is here. The x coordinate is 4, so we need to find the y coordinate. The y coordinate, I'm just gonna sub in as I did earlier. So y would be equal to, so let's say this is y1. So y2 would be what? I'm gonna substitute 4 here. So I'm gonna have 2 times 4 squared minus 8 times 4 times 2 plus 8 times 4, 32 plus 1. So this is the y coordinate, and this is equal to 4 squared is 16 times 2 is 32 minus 8 times 4 times 2 is 64 plus 32 plus 1. And all of this cancels out because 32 twice is 64, and this is equal to 1. Therefore the coordinate is 4, 1, and the nature is minimum. The nature is minimum because here we would have a minimum because the function is decreasing on the left and then increasing on the right.